In late 2025, something unusual happened in our solar system. 7 comets reached their closest point to the Sun within just a few months of each other. This wasn't a warning sign or a threat. It was a rare astronomical event that gave scientists an incredible opportunity to study these icy travelers, including one very special visitor from beyond our solar system. Debunking the myths. The internet went wild with videos and posts claiming NASA issued emergency alerts about comets diving toward Earth. Some people suggested alien spacecraft were hiding among them. The truth is far more interesting and way less scary. NASA never issued an emergency alert. What they did do was coordinate one of the most comprehensive comet observation campaigns in history, using spacecraft scattered across the solar system to capture images and data from multiple angles. What made this event so unusual? Before we dive into each comet, you need to understand what makes this gathering so unusual. On average, we see 1 or 2 bright comets per year that reach naked eye visibility. Having 7 comets hit their perihelion, the point where they get closest to the Sun, in a 6-month window is rare. Modern records going back to the early 1900s show no more than 4 bright comets appearing in a similar time frame. The last comparable event was way back in 1910 and 1911, when Halley's Comet showed up alongside several others. Why we're finding more comets than ever. Here's the thing about why we're seeing more comets now than ever before. It's not that more comets exist or that something strange is pulling them toward us. We've just gotten incredibly good at finding them. Before the year 2000, astronomers discovered maybe 10 bright comets per decade. Today, automated survey telescopes like ATLAS and Pan-STARRS scan the entire sky multiple times per month, finding 20 to 30 bright comets per decade. The ATLAS system alone discovers about half of all near-Earth objects annually. Better technology means better detection, plain and simple. The diverse origins of the 7 comets. The 7 comets in this group come from different parts of the solar system with wildly different histories. Some are short-period comets that swing by the Sun every few years. Others are long-period comets from the distant Oort cloud, a vast sphere of icy objects surrounding our solar system at distances up to 200,000 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, about 93 million miles. And then there's the star of the show, an interstellar visitor that came from another star system entirely. Let's break down each comet starting from number 7 and working our way to the most fascinating one. Number 7, 240P NE. Number 7 is 240P NE, a short-period comet discovered back in 2010. This one completes its orbit around the Sun every 7.6 years, making it a regular visitor. It reaches perihelion on December 19, 2025, at a distance of 2.12 astronomical units from the Sun. That puts it well beyond Earth's orbit, hanging out in space between Mars and the asteroid belt. With a magnitude of 13 or fainter, you'd need a decent telescope to spot this one. Most backyard telescopes can see objects down to magnitude 10 or 11, so 240P NE remained invisible to amateur astronomers. The scientists categorize it as a Jupiter family comet, meaning Jupiter's massive gravity has shaped its orbit over thousands of years. During its 2025 return, the comet showed minimal outgassing, a process where frozen materials turn directly into gas as the Sun heats the nucleus. Even though it wasn't spectacular to look at, comets like 240P NE help astronomers understand how these objects evolve over multiple orbits. Each time a comet swings close to the Sun, it loses material. Eventually, after thousands of passes, it becomes a dead rock or breaks apart completely. Number 6, C2022N2. Number 6 is C2022N2, discovered by the Pan-STARRS telescope in Hawaii on July 7, 2022. Pan-STARRS stands for Panoramic Survey Telescope and Rapid Response System, and it's been finding comets since 2010. This long-period comet took its sweet time getting here, finally reaching perihelion on July 31, 2025, at a distance of 3.82 astronomical units. That's nearly 4 times farther from the Sun than Earth is. At such a distant approach, the Sun's heat couldn't vaporize much material from the comet's nucleus. Observers at Lowell Observatory in Arizona noted a faint coma, a fuzzy cloud of gas and dust surrounding a comet's nucleus, but no prominent tail developed. Peak brightness hit magnitude 10, requiring professional equipment to see. The minimum distance from Earth was 2.5 astronomical units, about 232 million miles. So, there was never any chance of a close encounter. C2022N2 comes from the Oort cloud, that distant reservoir of comets left over from the formation of our solar system 4.6 billion years ago. Spectral analysis, where scientists split the comet's light into its component wavelengths, revealed typical ingredients like water, ice, and carbon compounds. While not a public spectacle, this comet provided valuable data about how volatiles, materials that evaporate easily, behave when solar heating is weak. Number 5, 414P stereo. Number 5 brings us to 414P stereo, a short period comet with an orbital period of about 5.5 years. The Stereo spacecraft discovered it in 2016. Stereo stands for Solar Terrestrial Relations Observatory, and NASA launched twin spacecraft to study the Sun from different angles. On September 27, 2025, 414P stereo reached perihelion at 0.52 astronomical units, closer to the Sun than Earth gets. The comet's orbit tilts below the ecliptic, the flat plane where most planets orbit, which created viewing challenges from Earth because the Sun's glare blocked it. Spacecraft like Solar Orbiter, which studies the Sun from various distances, captured images showing a compact coma and a short tail. At magnitude 12, this comet remained too faint for most amateur telescopes. Scientists find Jupiter family comets like this one particularly interesting because they've been captured and reshaped by Jupiter's gravity over time. Each close approach to the Sun risks breaking the nucleus apart. Rocky chunks held together by ice can only survive so many heating cycles before thermal stress causes them to fragment. Future observations of 414P stereo will reveal whether it survives long-term or joins the growing list of disintegrated comets. Number 4, C2025K1. Number 4 is C2025K1, discovered by the Atlas telescope in May 2025. Atlas operates 2 telescopes in Hawaii that can scan the sky for asteroids and comets that might pose a threat to Earth. C2025K1 reached perihelion on October 8, 2025, at just 0.33 astronomical units from the Sun. That's closer than Mercury's average distance of 0.39 astronomical units. Getting that close to the Sun subjects a comet to intense radiation and heat. The surface temperature can reach hundreds of degrees, causing rapid sublimation of ices and creating a bright tail. This comet peaked at magnitude 7 or 8, making it visible through binoculars under dark skies. Astronomers at Chile's Very Large Telescope, one of the most powerful ground-based observatories on Earth, detected sodium emissions in the comet's spectrum. Sodium shows up as distinctive yellow-orange lines and is unusual for comets because most of it stays locked in minerals unless heating becomes extreme. The presence of sodium suggested C2025K1 was really cooking as it rounded the Sun. As a long-period comet, it likely took thousands or millions of years to travel from the Oort cloud to its 2025 perihelion. The closest it came to Earth was 0.8 astronomical units, about 74 million miles, never posing any risk of impact. Scientists value close perihelion comets because the intense solar environment reveals composition details that wouldn't show up at greater distances. Number 3, C2025R2. Number 3 is C2025R2, discovered on September 11, 2025, by the SWAN instrument aboard the SOHO spacecraft. SWAN monitors hydrogen emissions across the sky, which makes it excellent at detecting comets even before they brighten enough for ground telescopes to spot. SOHO, the Solar and Heliospheric Observatory, has been stationed between Earth and the Sun since 1995, watching our star constantly. C2025R2 reached perihelion incredibly fast, just 1 day after discovery on September 12, 2025, at 0.50 astronomical units from the Sun. Then, on October 21, 2025, it made a close flyby of Earth at 0.25 astronomical units, roughly 23 million miles away. That's close in astronomical terms, though still about 100 times farther than the Moon. The comet brightened to magnitude 6, right at the edge of naked eye visibility, though binoculars provided much better views. Observers in the southern hemisphere got the best looks, reporting a greenish coma. That green color comes from diatomic carbon, created when ultraviolet sunlight breaks apart larger carbon molecules in the coma. The Hubble Space Telescope turned its powerful cameras towards C2025R2, and captured dramatic images of ion tail disruptions. Ion tails point directly away from the sun, pushed by the solar wind, a stream of charged particles constantly flowing outward from the sun. When the solar wind fluctuates, especially during coronal mass ejections, it can actually sever the ion tail. The tail breaks off and a new one grows within hours. These disconnection events provide real-time data about how the solar wind and magnetic fields interact with cometary material. The composition of C-2025-R2 included high volatile content, materials that vaporize easily, which explained its rapid brightening as it approached the sun. Number 2, C-2025-A6, Comet Lemon. Number 2 brings us to C-2025-A6, known as Comet Lemon because it was discovered at the Mount Lemmon Observatory in Arizona on January 3, 2025. Astronomers found pre-discovery images from November 2024 showing the comet was there but too faint to notice initially. Lemon reached perihelion on November 8, 2025 at 0.53 astronomical units from the sun. Predictions suggested it would brighten to magnitude 3.5 or 4, potentially making it the brightest comet of the entire 7. At magnitude 4, the comet becomes visible to the naked eye from locations with reasonably dark skies away from city lights. Northern Hemisphere observers got lucky because Lemon appeared in the evening sky after sunset in the constellation Boötes. This timing meant people could step outside after dinner and spot it without waking up before dawn. The comet developed a broad dust tail, a curved tail made of tiny particles that reflect sunlight. Dust tails follow slightly different paths than ion tails because the particles have mass and respond to solar radiation pressure more slowly. With an orbital period of approximately 1,350 years, C-2025-A6 last visited the inner solar system around the year 675, long before telescopes existed. It'll return around the year 3375, and nobody alive today will see it again. Comets like Lemon preserve pristine materials from the early solar system because they spend most of their time frozen solid in the Oort cloud, protected from the sun's transforming heat. Number 1, 3I Atlas, the interstellar visitor. Now we reach number 1, the comet that captured worldwide attention and generated countless conspiracy theories. Meet 3I Atlas, officially designated C-2025-N1, the third confirmed interstellar object ever detected visiting our solar system. The Atlas telescope in Chile discovered it on July 1, 2025. Right away, orbital calculations revealed something extraordinary. This comet wasn't bound by the sun's gravity. Its orbital eccentricity measured greater than 1, specifically 6.14, meaning it follows a hyperbolic trajectory. Objects with eccentricity less than 1 are locked in elliptical orbits, doomed to circle the sun forever. Objects with eccentricity exactly equal to 1 follow parabolic paths, barely escaping. But eccentricity above 1 means the object came from interstellar space and will return to interstellar space, never to come back. 3I Atlas approached from the direction of the constellation Sagittarius, traveling at peak speeds of up to 153,000 miles per hour, or 68 kilometers per second, at perihelion. That speed exceeds the solar system escape velocity at that distance, proving its extrasolar origin. The closest approach. On October 30th, 2025, 3I Atlas reached perihelion at 1.4 astronomical units from the Sun, passing between Earth's orbit and Mars' orbit. Came closest to Earth on December 19th, 2025 at 1.8 astronomical units, about 167 miles away. NASA mobilized an unprecedented observation campaign, coordinating over a dozen spacecraft to study this rare visitor. Observations from Mars. The Mars fleet provided the closest views. Mars Reconnaissance Orbiter, which has been mapping Mars since 2006, used its HiRISE camera to capture high-resolution images of the comet's coma and tail. MAVEN, the Mars Atmosphere and Volatile Evolution spacecraft, detected a gas halo around the nucleus using ultraviolet instruments. Even the Perseverance rover on Mars' surface captured views of the comet in the pre-dawn Martian sky. These observations occurred during the comet's flyby on Mars at just 19 million miles, closer than the comet ever came to Earth. The Psyche spacecraft, currently traveling toward a metal-rich asteroid, interrupted its cruise to photograph 3I Atlas over an 8-hour period, revealing how the tail evolved in near real time. What Hubble and Webb revealed. Back in Earth orbit, the Hubble Space Telescope and James Webb Space Telescope analyzed the comet's composition in detail. Hubble estimated the nucleus size between 440 meters and 5.6 kilometers in diameter, roughly 1,400 feet to 3.5 miles. That size range comes from measuring the brightness and making assumptions about how reflective the surface is. Darker surfaces reflect less light, so if the comet's nucleus is very dark, it must be larger to produce the observed brightness. Spectral analysis revealed an unusual composition dominated by carbon monoxide with high carbon dioxide content. Most solar system comets are rich in water and ice, but 3I Atlas showed depleted carbon chains and odd chemical signatures. One particularly intriguing detection was nickel without iron. In solar system comets, nickel and iron usually appear together in similar ratios, but 3I Atlas broke that pattern. Scientists interpret these compositional differences as evidence that 3I Atlas formed in a different stellar system, different conditions than our sun's protoplanetary disk had 4.6 billion years ago. The comet's blue hue, visible in color images, comes from carbon dioxide sublimating from the nucleus, another unusual characteristic. Conspiracy theories and NASA's response. The weirdness of 3I Atlas triggered wild speculation online. Videos claimed NASA was hiding evidence of alien technology. Some pointed to non-gravitational forces acting on the comet. Acceleration is not explained by the sun's gravity alone. These forces, described by parameters called A1 and A2 in orbital calculations, result from jets of gas erupting from the nucleus. As frozen material turns to gas on the sunny side of the nucleus, it shoots outward like rocket exhaust, giving the nucleus a tiny push. This effect is well documented in comets and perfectly natural. The jets from 3I Atlas remained collimated, staying narrow and focused over distances exceeding 1 million kilometers. Other conspiracy theorists noted unusual plumes containing cyanide compounds. Cyanide sounds scary because it's toxic to humans, but comets routinely contain hydrogen cyanide and other cyanide compounds formed from carbon, nitrogen, and hydrogen in space. It's completely normal for cometary chemistry. NASA addressed all these rumors head-on. Nicola Fox from NASA's Science Mission Directorate stated that all evidence points to 3I Atlas being a natural comet. No technosignatures appeared in any data. Technosignatures are artificial patterns or structures that would indicate intelligent design like radio transmissions, geometric shapes, or materials that don't form naturally. Scientists found none of that, just a comet behaving like a comet, albeit one from another star system. The Mars observations allowed NASA to refine the comet's trajectory with 10 times higher accuracy than before, improving planetary defense models. If a future interstellar object did pose a collision risk, techniques developed studying 3I Atlas would help predict its path precisely. Comparing the 3 interstellar visitors. Comparing 3I Atlas to the 2 previous interstellar visitors show how diverse these objects are. The first, One-Eye Oumuamua, discovered in 2017, looked more like an asteroid than a comet. It showed no visible coma or tail, tumbled through space end over end, and measured perhaps 100 to 200 meters long. Its speed at perihelion reached 87 kilometers per second. The second, 2-Eye Borisov, discovered in 2019, clearly displayed cometary activity with a prominent hydrogen-rich coma. Its nucleus measured roughly 1 kilometer across, and it traveled at 32 kilometers per second. Borisov later disintegrated, breaking into multiple fragments that faded from view. Now, 3I Atlas, measuring between 440 meters and 5.6 kilometers, traveling at 68 kilometers per second, adds more data points to our understanding of interstellar objects. Scientists estimate that thousands of interstellar objects pass through the inner solar system each year. Most go undetected because they're small, dark, or visit when our telescopes aren't looking the right direction. Improved survey telescopes should find more in coming years. Solar activity in the comet swarm. What about solar activity and interactions between these 7 comets and the Sun? The year 2025 sits near solar maximum, the peak of the Sun's 11-year activity cycle, when sunspots, flares, and coronal mass ejections become more frequent. Some online sources claim the comet swarm would trigger massive solar storms. NASA's monitoring showed nothing unusual. Coronal mass ejections average 2 to 5 per week throughout this period, completely normal for solar maximum. Comets can experience tail disconnections when they encounter CMEs, as happened with C225R2, but the comets don't cause the CMEs. The Sun produces these eruptions based on its own internal magnetic dynamo. Solar Orbiter and Parker Solar Probe, 2 spacecraft studying the Sun up close, monitored for any unusual activity during the comet passages and found none. Comets travel too far from the sun's surface to trigger flares, and their combined mass is negligible compared to the sun's bulk. No meteor showers expected. As for meteor showers, don't expect any from these 7 comets. Meteor showers occur when Earth passes through debris trails left by comets, like how the Perseids come from Comet Swift-Tuttle and the Orionids come from Halley's Comet. The 2025 comets never came close enough to Earth's orbit to leave debris in our path. The closest approach by C-2025-R2 at 0.25 astronomical units still missed Earth by a huge margin. Dust trails from 3I Atlas might persist for years, spreading along its hyperbolic trajectory, but Earth won't intersect that path. In 2026, astronomers will watch for any lingering effects or faint meteor enhancements, but predictions suggest nothing significant will develop. The technology that made discovery possible. The detection technologies deserve credit for making this event possible to study in such detail. The Atlas system uses relatively small telescopes, just 0.5 meters in diameter, but covers the entire sky that's visible from Hawaii every 24 hours. Computers compare each night's images to previous nights, flagging anything that moved or changed brightness. When a new comet appears, astronomers worldwide receive automatic alerts and can point larger telescopes at it within hours. Pan-STARRS operates similarly, but with 1.8-meter telescopes, giving it the ability to see fainter objects. Between these systems and others like the Catalina Sky Survey, we've entered an era where few bright comets escape detection. That's why the 2025 event seems so dramatic. We caught all 7 comets, whereas a century ago we might have missed most of them. Looking to the future. Looking forward, the European Space Agency plans to launch Comet Interceptor mission in 2029. This spacecraft will park at a gravitationally stable point in space, waiting for a new long-period comet or interstellar object to be discovered. When a suitable target appears, the spacecraft will leave its parking spot and fly out to meet the comet, potentially arriving while it's still fresh and unaltered by the sun's heat. If another object like 3I Atlas shows up, Comet Interceptor could chase it down and return close-up images and data that spacecraft near Earth can't capture. NASA is also developing improved survey telescopes like the Near-Earth Object Surveyor, scheduled to launch later this decade, which will operate from space and detect objects too faint for ground-based telescopes. What this event taught us. The convergence of 7 comets in 2025 reinforced how much we've learned about these ancient travelers and how much remains to be discovered. Each comet tells a story about where it formed, what it experienced during billions of years in deep freeze, and how it responds when the sun's energy finally reaches it. 3I Atlas adds a chapter about another star's planetary system, carrying chemistry and materials forged from a different sun. The event also demonstrated how global cooperation in astronomy benefits everyone, with NASA, ESA, and observatories worldwide sharing data to build a complete picture. So, no, there wasn't an emergency. No aliens were hiding among the comets. No solar storms ravaged Earth. What we got was something better. A chance to witness and study a rare clustering of comets, including our 3rd ever interstellar visitor, using the most advanced tools humanity has ever built. The universe brought us a gift. Scientists around the world unwrapped it together, sharing what they found with everyone who cared to look up.